Dear students, today we'll start with Castigliano's theorem examples for a frame, a bent frame. Determine vertical displacement of free end D. EI is 12 into 10 raised to 3 Newton mm square. So this is the beam, a bent frame. Let this be A, B, C and D. I have to find vertical displacement of free end D, vertical displacement of this. Now if you look at this problem, there is no point load at D. So I have to apply a virtual load. And before applying that, let me draw a same frame as it is. Apply same loads. This is the UDL. This is the point load acting. Now I have to find vertical displacement of point D. So apply a force like this. Let this force be P. Now how to decide which will be positive moment and which will be negative moment? Always sagging moments are positive, hogging moments are negative. For this I will find a simple term. Simply draw a dotted line inside the frame. Any force, if it causes bending moment, tension on the dotted line side, it means that moment or that force is taken as positive. If moment causes tension on the dotted side line, so moment on this side here for this beam, this side, if on this side, if it causes tension, I am going to consider that as positive. This is the simple thumb rule. We will write that note. Moment is positive if it causes tension on dotted side. Tension means elongation. There is increase in length, that is tension. Now, since there is no load at point P, no load at point D, apply a unit vertical load at D because I am required to calculate vertical displacement. So apply a unit vertical load point P at point D. Since there is no load at D, apply dummy vertical load P at point D. So I have to apply that in vertical direction. Now let me put the table. Since there are three beams, three individual parts, let me write it like this. So start from here, from D, DC, CB and BA. So DC, CB, BA. Origin, limit, M, EI. Now for DC, I have to take the sections. How I will take the sections now? Just look here. From D, go towards C. From C, go towards B. From B, go towards A. This is how we are going to consider the sections. DC, origin is D. Limits means distance is 0 to 2. Now, moment at this section because of this load. Since this load is acting in line of this beam, perpendicular distance is 0. So moment here will be 0. 0 EI. Now come to CB. Origin is C. I have to consider this much portion of the beam. Whatever is remaining, this portion just forget it. Now here there are two loads. One is this point load, second is this UDL. So moment at this section because of this point load P. Load into perpendicular distance. Load is P, perpendicular distance is X. Now remember, this P is going to act like this. So it will bend like this. When it bends like this portion is in tension, this portion is in compression. And what my sign convention says, if moment causes tension on the dotted side, it is positive. Here this moment is causing compression on dotted side. So I am going to make that as negative. So here there are two loads. One is load P, second is this UDL. Load P is P into X, perpendicular distance Px. Now moment due to this UDL, 30 into X by 2. So sign will be negative. So moment here, so 0 to 4. Now moments here, minus of load into perpendicular distance P into X plus, means minus sign I have taken it outside, 30 into X by 2. So 15X square. 15X square. EI value is EI as it is. Now come to portion BA here at this section. So here at this section two loads are there, P and 30. So first let me complete this. Origin is B, limits are 0 to 4. Now here this load P, this load is acting here and perpendicular distance is this much, 4 meters. So 4 into P. This is going to act like this. So it causes tension outside, compression inside. So I am going to make it negative. Minus load into perpendicular distance P into 4 or minus 4P. Next, because of this UDL is acting at CG point here. It is somewhere at the center. So moment at this point because of this UDL is load into distance into CG. So load is 30, distance is 4. This distance is given as 4 meters. 30 into 4, CG distance, half of it, 4 by 2. So 30 into 4 into 2, 240. Then also this load is also acting, 50 kilonewtons load. So load into perpendicular distance, 50 into X. Again my same sign convention. It causes tension top side, compression on the bottom. So minus 50 into X. So minus is common. I am going to take that outside the bracket. Minus. So because of point load, 4 into P. Because of that UDL, 30 into 4 by 2. Solving that you get 240 plus 50X. EI common as it is. Now I will substitute the values and start with the integration. Now we have strain energy is equal to m square by 2EI dx, 0 to L. Now I have to write for each of the terms separately. So first term m is 0, so 0, 0 plus. Now this second m square, so minus square, it becomes positive. So simply make it positive, 0 to 4, px plus 15x square. So start substituting the values. So px plus 15x bracket square divided by 2EI plus 0 to 4 this bracket square, 4p plus 240 plus 50x whole bracket square divided by EI. Now here by Castigliano's theorem what it says is delta is equal to dou u by dou p, partial differentiation of u with respect to p is equal to, forget this, now come here p term is here, so differentiation of this bracket square is differentiation of some function into square, so 2 into this, then differentiation of this term, so I have the value partial differentiation inside the integration term itself, 2 into px plus 15x. Now differentiation of px with respect to dx, it gives me it gives me x divided by 2ei dx plus partial differentiation of this term 0 to 4, 2 into 4p plus 240 plus 50x. Now differentiate this term with respect to p, so d by dp of 4p, so you are left with 4 divided by 2ei. This 2 gets cancelled, here this 2 and this 2 it gets cancelled. Now since p is dummy load, put p is equal to 0. When I put p is equal to 0, this term becomes 0, this term becomes 0. Now again simplify it, is equal to 0 to 4 15x square by ei plus 0 to 4, here 4 into 240 plus 50x, 4 into 240 plus 50x divided by ei dx. Now differentiate the things, 15 by ei outside the bracket constant, integration of x square is x cube by 3, 0 to 4 plus 4 into 240, so 4 by ei, integration of 240 is 240x 0 to 4 plus 150x, sorry it is 50x not 150, it is 50x plus 50 by ei outside the bracket, so integration of x is x square by 2, 0 to 4. You substitute all the values and get delta c, you will get 6400 by ei. This is the deflection of c. Now we have values of ei, substitute them and get the final answer. So we are having the value delta c is 6400 by ei. Now ei is given as 12 into 10 raised to 13 Newton mm square. I have to convert this into kilonewton and meters. So first write the value as it is, 12 into 10 raised to 13, this Newton into kilonewton. 1 Newton is 10 raised to minus 3 kilonewtons. Then mm into kilonewtons into 1 mm is 10 raised to minus 3 meters bracket square. So this gives me 12 into 10 raised to 13 into 10 raised to minus 3. 10 raised to minus 3 square is 10 raised to minus 6. Minus 3 minus 6 minus 9 plus 13. So I am left with 12 into 10 raised to 4 kilonewton meter square. So substitute the values. Delta C is equal to 6400 by 12 into 10 raised to 4. So you will get the answer 0.0533 meters or 53.33 mm. This is the final answer. So similarly we can calculate horizontal displacement of point D. We will take up that in the next problem. Thank you.